Hi, welcome to the notes on forces and friction. Here are the words to know for this unit. The key questions for this unit are: what is force and how is it measured? How is motion affected by balanced and unbalanced forces? What is friction? What are the four types of friction? We first need to know what force is and how to measure it. A force is a push or a pull, and a force is measured in the metric unit Newton, named after Sir Isaac Newton. 1 Newton is equal to 1 kilogram times 1 meters per second squared. Recognize that this is a mass, and this is a measurement of acceleration. So we're only going to be able to accelerate things that have mass. So when we push on things, we will make the thing with mass move by causing it to accelerate. To measure force, we will be using a spring scale. There's a lot of different kinds of spring scale. We'll be using one mainly that looks like this, just like in this picture. Also to note, when we talk about forces, we need to understand that it has a directional component. It's based on acceleration, which is derived from velocity, which is speed with a direction. So all of these have a direction, and we show that direction of force with an arrow. And usually when we see force diagrams, the size of the arrow does connotate or show how big that force is. There's also usually a number to go with it. How is motion affected by balanced and unbalanced forces? An unbalanced force can cause an object to start moving or change its motion. Here's a circle. We did some boxes in class earlier. We're going to draw arrows of force so the circle moves to the right. Let's go ahead and do that. Let's see if you can draw an arrow on here to make it move to the right. Here you notice I've drawn an arrow. You might have drawn one similar to this. It just shows a force pushing on it from that left side to make it go to the right. Now, draw one that'll make this circle go to the left. So now you may have drawn one similar to what I drew on here. Remember, when we've done this before in class, we've also written in the amount of force on here. So you can write any amount of newtons if you want here to show how many newtons of force was used here. Any number can be done here, it doesn't matter. Balanced forces will not change an object's motion. Balanced forces are equal and opposite. Draw arrows of force that are balanced. So now take a moment on your paper, draw arrows that'll balance this out. Also, put some numbers on there. Put some forces on there to show that they are indeed balanced. How'd you do? I'll go ahead and do this for you. Try to draw an arrow here. Okay, I'll draw hopefully a similar one of same size over here, and I'll just put the same amount of force on each side to show that it is indeed balanced. We also could have done it, up and down. We could have had some force up here, some force down here. That was the same as well. Multiple forces acting on an object are represented by multiple arrows. All the forces put together are called the net force. What is the net force on this circle below? In what direction will it go? All right, I want to go ahead and draw some on here, and you tell me what the final net force is. So what is the net force? How much do we have on this side? It looks like on this side we have a total of 4 newtons. pushing it to the right. Over here we only have 3 newtons, pushing it to the left, so we're going to have a total of 1 newton pushing to the right. Now we need to understand balanced and unbalanced forces to know something about friction. Friction is a force that opposes motion and a force that of one surface exerting on another when they rub together. Just like if you take your hands and you rub them together and it gets all hot, all right, that is friction. And friction slows things down. It's an unbalanced force. It's going to go in the opposite direction that you're going to be pushing in. So just like in this picture here, we see motion pushing one direction, going one way. Friction is the unbalanced force pushing in the opposite direction. There are 4 types of friction. There's what's called static friction, and this is between 2 objects that are in contact and are not moving. In static friction, it's generally greater than sliding friction and must be overcome before an object can be set in motion. So this is a case when you first need to move something and it's really heavy and you can't seem to get it going. That's that static friction. You kind of got to get it moving first. And once you get it over that initial static friction, it becomes a little easier to move because then you're using sliding friction. Sliding friction is going to occur when we just have some dragging or pushing something across a flat surface, right, a floor. Or some other surface, just like a refrigerator or a box, something that you're moving, just sliding friction. Rolling friction, this is a less amount of force than sliding friction. It's easier to roll things on wheels, right? It takes less force. So rolling friction is less than sliding friction. Another type of friction that we need to be familiar with is fluid friction. Air and water are both considered types of fluid. In airplanes, and ships, and cars, everything that needs to take into account aerodynamic drag. That's when we're talking about fluid friction, the movement of air or water around something. So just like we can see in these pictures here, we have an entry photograph on the left of the space shuttle coming in and the heat produced from friction. It's a great amount of heat. And on the right side, we see a car that shows its streamlined aerodynamic qualities having to do with reducing that amount of fluid friction. Right? The more aerodynamic a car is, the less friction it has, the more fuel efficient it will be, and the faster it can go as well. And that's it for these notes on forces and friction.